Hey everyone, and welcome. Today we are jumping right into one of the most powerful ideas in all of programming, repetition. We're going to master the art of Java loops, and I'll show you how to turn those tedious repetitive coding tasks into super clean automated solutions. All right, let's get started.
One of the very first rules they teach you in coding, and probably the biggest mistake you can make, is repeating yourself. Just writing the same chunk of code over and over again. It makes your program huge, and trust me, it becomes an absolute nightmare to fix or update later on.
And that's where this golden rule comes in, the DRY principle. It literally stands for don't repeat yourself. The whole idea is to be efficient, to keep your code clean, and, well, to keep your sanity. You want to make a change in just one place, not hunt it down in 10 different spots. So, that's the big question, right? How do we actually do this? How can we tell a computer, hey, do this thing 100 times, without us having to physically type out that instruction 100 times?
Well, the answer, and this is really the heart of what we're talking about today, is the loop. A loop is the programmer's ultimate tool for handling any task that needs to happen more than once. It's pure elegance.
Seriously, think of loops as the engine of automation in your code. You just define a block of instructions once, you tell it the rules, and then you just let it run. It does all the heavy lifting for you.
All right, so let's get into our toolkit. First up, we have the for loop. I like to think of this as the precision instrument of the looping world. This is your go-to when you know exactly how many times you need to do something.
It's kind of like following a recipe that tells you, hey, stir this thing exactly 10 times. No more, no less. That's a for loop. It's perfect for any situation where the number of repeats is set in stone before the loop even begins.
So when you look at a for loop, it's really made up of three essential pieces. First, you've got the initialization. That's where you start your counter. Second is the condition. The loop will keep running as long as this is true. And third is the update. This is what changes the counter after every single pass.
Okay, let's look at a real example. See? Right here, int I equals 0. We're initializing our counter I and setting it to 0. Then the condition, I is less than 10, tells the loop to keep going as long as I is less than 10. And finally, plus I, the update, just adds 1 to I after each cycle. These three parts work in perfect harmony to control the loop.
And boom, here's what you get. The code prints the numbers 0 all the way up to 9. The second I hits 10, that condition I is less than 10 is suddenly false, and the loop just stops. It's perfect, completely predictable repetition. Okay, that's great for when we know the exact number. But what if you don't? What if you just need to keep doing something until a certain thing happens? For that, we've got another tool, the while loop.
And this is really the fundamental difference you got to remember. A for loop is for counting. A while loop is for checking. You use a while loop when you need to repeat something as long as a condition is true, like, say, waiting for a user to enter the right password. You have no idea if it'll take them 1 try or 20 tries.
So take a look at the structure here. It's a bit simpler, right? The while loop really only has the condition. The setup, the initialization happens before the loop starts, and the update happens somewhere inside the loop's code block. We call this a pretest loop because it checks that condition, count less than 10, before every single run. Now there's this other flavor of the while loop, called a do-while loop. It's a post-test loop, which means it runs the code first and then checks the condition. This guarantees the code will run at least one time, which is actually perfect for things like showing a user a menu. You have to show them the options at least once before you can ask them to make a choice.
All right, so loops are powerful, but what if you want to be the puppet master? What if you need even more control? Maybe you need to bail out early or just skip a particular step. Well, Java gives us a couple of keywords to do just that.
You get these two little magic words, break and continue. Think of break as pulling the emergency brake on a train. It just stops the loop dead in its tracks, right then and there. Continue, on the other hand, is more like hitting the skip track button on your music player. It just ends the current round and jumps straight to the start of the next one.
So check this out. We've got a loop that looks like it should count to 10. But there's a catch inside. We've added a little condition. If count is ever equal to 5, we hit that break statement, and that's it. Game over for the loop.
And just look at the output. It prints 0, 1, 2, 3, 4, and then it stops. Dead. The second count becomes 5. That if statement triggers the break, and we're kicked out of the loop completely. The numbers 5 through 9 never even get a chance to be printed. And this is where things can get really wild, in a good way. You can put loops inside of other loops. We call these nested loops. This is an absolutely crucial technique for more complex jobs like working with grids or tables of data. A classic example is in a video game where you might have the main gameplay loop running inside of a bigger main menu loop.
So, this all seems great in theory, but where do you actually use this stuff in the real world? Let's connect these ideas to some actual practical programming tasks you'd see every day.
Oh, they are literally everywhere. You know when a website keeps asking for your age until you finally enter a positive number? That's a while loop. Building those interactive menus in an application that wait for you to make a choice? That's a loop. And for loops are the absolute best for things like calculating the total sum of a list of numbers. Loops are truly the workhorses of modern software.
So, I'll leave you with this thought. The next time you find yourself doing the same thing over and over again, try to think like a programmer. What's that repetitive task in your own life that could probably be solved with a loop? Thanks for joining me on this deep dive into Java loops.